Yo, what's up everyone, it's Rahul here and welcome back to the channel. Today we're diving deep into the world of data structures and algorithms. It doesn't matter if you're just starting out or if you've been coding for a while and want to refresh your knowledge. This video is your one-stop shop for understanding these fundamental concepts. We're gonna break down complex ideas into bite-sized pieces, so you can really grasp the how and the why behind these building blocks of computer science. From arrays and linked lists to trees and graphs, we'll cover it all, and we'll even touch on some of the coolest algorithms out there. So, whether you're aiming to ace that coding interview, build the next killer app, or simply level up your programming game, stick around and let's get started. First up, we're tackling arrays. Imagine these as neat, organized containers holding a sequence of elements. Think of it like a row of lockers, each with its own designated spot. Arrays are all about efficiency. You can access any element directly using its index, kinda like using a locker number to find what you need instantly. But arrays are more than just storage, they're also the playground for some really slick algorithms. We'll dive into sorting techniques like quick sort, which is like finding that perfectly ordered bookshelf in record time, and merge sort, which is all about merging those sorted piles into one masterpiece. And let's not forget searching algorithms like binary search. It's like finding that one book you need in a massive library, but instead of checking every single book, you're strategically narrowing down your search. Next up, we're exploring linked lists. Think of these as a chain of elements, where each element points to the next one in line. It's like a treasure hunt, where each clue leads you to the next until you find the treasure. We'll cover how to traverse through a linked list, how to add or remove elements at any given point, and even some cool tricks like reversing a linked list without breaking a sweat. And of course, we can't forget about cycle detection using Floyd's tortoise and hare algorithm. It's like making sure our treasure hunt doesn't turn into an endless loop. Now let's talk about hash tables. Imagine a super efficient lookup system where you have keys, like words in a dictionary. And each key is directly associated with a value, like the word's definition. Hash tables are all about speed. They use clever functions to quickly find the information you need. We'll explore how hash functions work, how to insert, delete, and search for elements in a flash, and how to deal with those pesky collisions that can happen when different keys map to the same location. It's like having a well-organized library where you can find any book instantly, even if there are multiple copies. Trees, branching out with hierarchical data. Time to climb the data structure tree. Literally, trees are hierarchical structures with a root node at the top and branches of child nodes extending downwards. Think of it like a family tree, but for data, we'll delve into different types of trees, like binary search trees, and learn how to traverse them using methods like in-order, pre-order, and post-order. Plus, we'll master the art of searching for specific nodes within a tree, because who doesn't love a good tree search? Stacks, last in, first out, LIFO, in action. Let's talk about stacks. Imagine a stack of plates where you can only add or remove plates from the top. That's the LIFO principle in action, last in, first out. Stacks are super useful in programming. We'll break down the core operations: push, which is like adding a plate to the top, pop, which is like removing a plate, and peek, which is like taking a sneak peek at the top plate without disturbing the stack. Queues, first in, first out, FIFO, explained. Now let's queue up for queues. Think of this like a line at a theme park. The first person in line gets to ride first, that's FIFO. First in, first out. Queues are essential for managing tasks in the right order. We'll cover the two main operations: on queue, which is like joining the back of the line, and dequeue, which is like reaching the front and exiting the queue. Next up, we're diving into heaps. Imagine a special kind of tree where the most important element is always at the top, like a priority list that automatically sorts itself. We'll explore how to insert and delete elements in a heap, how to build a heap from scratch, and how to use heaps to quickly find the top K elements, because who doesn't love a good top 10 list? Let's map out the world of graphs. Imagine a network of nodes connected by edges. Think social networks, maps, or even the internet itself. Graphs are everywhere. We'll explore different types of graphs, learn about traversal methods like breadth-first search and depth-first search, and uncover algorithms like Dijkstra's algorithm, which is like finding the fastest route on a map. Plus, we'll learn how to detect cycles and graphs, because sometimes you just want to know if you're going in circles. Time to branch out with tries. Tries are specialized tree-like structures perfect for storing and searching words and prefixes. Think of them as supercharged dictionaries. We'll learn how to implement a try from scratch, how to insert and search for words and prefixes with lightning speed, and how tries power those awesome auto-completion features we all love. Last but not least, let's connect with Union Find. This algorithm is all about efficiently grouping elements together based on their relationships. We'll cover how to implement Union Find, master its key operations find and union, and see how it can be used to detect cycles and graphs, because sometimes it's all about connecting the dots. So there you have it, a crash course on the most essential data structures and algorithms out there. I hope you enjoyed this deep dive as much as I did. Remember, mastering these concepts takes time and practice, but the rewards are huge. Whether you're building the next big thing or just want to write cleaner, more efficient code, understanding these building blocks is crucial. So keep experimenting, keep coding, and keep pushing your limits. Thanks for watching, and don't forget to like, subscribe, and hit that notification bell so you don't miss out on future tech deep dives.